Hi students, in this video I am going to discuss about the second law of thermodynamics. This topic is from Thermodynamics, unit number 2. After studying this video, you shall be able to know the limitation of first law of thermodynamics, then learn about some thermodynamic terms required for second law of thermodynamics, that is spontaneous process and non-spontaneous process. We already know about the first law of thermodynamics and the mathematical expression for first law of thermodynamics. According to first law of thermodynamics, the first law of thermodynamics tells us that energy can be changed from one form to another, but can be neither created nor destroyed in any process. The mathematical expression which is used to represent the first law of thermodynamics is delta U is equal to Q plus W, where delta U refers to the internal energy change and W is the amount of work, Q is the amount of heat. The first law of thermodynamics is concerned with the conversion of energy from one form to another. It helps us to understand energy transformation in different chemical reaction. The essence of first law of thermodynamics is that all physical and chemical processes are occurring in such a way that the total energy of the system and the surroundings is constant. However, it suffers from the following limitations. The limitation number 1 is the law does not give any information about the direction in which flow of energy takes place. That is, for example, it puts no restriction on the direction of the flow of heat, whether heat can flow from a cold body to a hot body or vice versa. That is, if two systems A and B, which are capable of exchanging heat, are brought in contact with each other, first law tells only one system loses energy and the other gains the same amount of energy. It fails to tell whether the heat will flow from A to B or B to A. That is, the law does not give any information about the direction in which the flow of energy takes place. The second limitation is it does not tell whether a chemical reaction is spontaneous or not. The third limitation is it does not provide and specify sufficient condition for the process to take place. And the fourth one is it states that energy can be converted one form into another, but it does not tell that heat energy cannot be completely converted into equal amount of work. The above limitations shows the insufficiency of first law of thermodynamics. The first law does not determine the feasibility or spontaneity of a reaction. The spontaneity or feasibility of a physical or chemical process is decided by the second law of thermodynamics. To overcome this limitation, another law is needed, which is known as second law of thermodynamics. This is the origin of second law of thermodynamics. However, before we study this law, let us understand the term spontaneous process, non-spontaneous process, driving force for spontaneous process, entropy and free energy. The second law of thermodynamics helps us to predict whether the reaction is feasible or spontaneous or not. It tells the direction of the flow of heat. It also tells the heat energy cannot be completely converted into equivalent work. Let us move on to the next topic, what is meant by spontaneous process. A spontaneous process which has a natural tendency to occur either of its own or by after proper initiation under the given set of conditions is known as spontaneous process. Spontaneous processes are also called feasible process or probable process. The actual rate of the process may vary from, that means actual rate of the spontaneous process may vary from very slow to extremely fast. Resting of ion is an example of slow process. Neutralization of acid and base is a fast spontaneous process. All natural processes are spontaneous and irreversible. There are some process which require some initiation before they can be proceeded, but once initiated, they proceed by themselves. This type of process are also called a spontaneous process. Finally, we can say that spontaneous process are the process which has a natural tendency to occur either of its own or by proper initiation. Here I am giving examples for spontaneous process where no initiation is needed. That means it takes place its own. Example number 1 is dissolution of sugar or salt in water. Second one is evaporation of water, heat flow, a hot body to cold body, mixing of different gases, downward flow of water, that means flow of water from higher level to lower level, then melting of ice, then nitric oxide and oxygen reacted to form nitrogen dioxide, etc. These are the examples of spontaneous process where no initiation is required. Then spontaneous process where some initiation is needed. Example is reaction between the hydrogen and oxygen to form water, combustion of carbon, methane, in etc. in presence of oxygen, decomposition of calcium carbonate, that is calcium carbonate on heating to give carbon dioxide and calcium oxide. These are the examples of spontaneous process where some initiation is needed. Here I am giving diagrammatic representation of some spontaneous process and non-spontaneous process. Cliff jumping is a spontaneous process while mountain climbing requires work, therefore it is not a spontaneous process. Second one is heat flow from higher temperature to lower temperature is a spontaneous process. Then flow of gases from high pressure to low pressure is a spontaneous process. A reverse process is non-spontaneous. Let us move on to the next topic, non-spontaneous process. A process which can neither occur by itself nor by initiation is called non-spontaneous process. It is the reverse of the spontaneous process. Example of non-spontaneous process is flow of water up a hill, that means flow of water from lower level to higher level. And then second one is flow of heat from cold body to a hot body, diffusion of gas from low pressure to a high pressure, and the fourth one is electrolysis. These are the examples of non-spontaneous process. Now let us summarize what you learned in this video is limitation of the first law of thermodynamics, then origin of the second law of thermodynamics, definition of non-spontaneous process, examples of non-spontaneous process where initiation is required and no initiation is required, then non-spontaneous process, examples of non-spontaneous process. Okay, thank you.